Good afternoon, everyone. So, in the previous classes, we have discussed about what an Ethereum blockchain is. We have discussed about Ethereum wallets and the Ethereum accounts. So, we know that we have two types of accounts, which we have previously discussed, the externally owned accounts and contract accounts. Okay. So, if you recall, externally owned accounts are the most basic type of accounts. Okay. You do not have any code associated with them. But if you look at a contract account here, a contract account is a smart contract account. Okay. So, this externally owned account is controlled by a private key, whereas a contract account is deployed on Ethereum and it has a unique Ethereum address. So, externally owned account can initiate transactions, that is transferring money, that is transferring ether from one account to another. But contract account cannot initiate transaction. They can only initiate transactions in response to some transaction. So if you recall the previous class, we have already discussed about the differences between the externally owned accounts and the contract account, and the differences between an Ethereum account, an Ethereum wallet, and an Ethereum address. Okay, so today what we'll do is we'll get into more detail about what an Ethereum account state is. That is, if you're talking about an Ethereum account, exactly what kind of information does your account store? Okay, so we will discuss that today. Next, if time permits, we will talk about Ethereum transactions, and we'll also get into detail about what is gas, how payments are made, how transactions are initiated. So we'll see each of this one by one. So we'll firstly talk about the account state. Okay, so by account state, what we mean is that whenever we are talking about an Ethereum account, be it an externally owned account or a contract account, these both of these accounts will have some types of components. And these are present regardless of the type of account we are talking about. It could either be externally owned or it could be a contract account. So there are four fields that are used here. Okay. The first is nonce. So if you look here, the first field mentioned is nonce. Now, can anybody tell me what does nonce mean with respect to Bitcoin? Anyone? We have already used this term nonce. Can anyone tell me what did this term nonce mean? What did it mean when we were talking about it with respect to the Bitcoin blockchain? Anyone? Any one of you who could tell me what nonce means? So, just to summarize, what exactly you did was you used your previous hash. Okay, yes, it is a number used with the previous hash and the Merkle root hash. So you keep incrementing this number in order to get a hash which is less than the difficulty target. Exactly, very good. But if you look here, we have a nonce in the account state. Okay, and it says that nonce with respect to Ethereum here means the number of transactions that have been sent from the account's address. Okay, so now this becomes confusing. Previously, we were saying that when we were using proof of work, then there was this number nonce that we used. But if you look here in the definition, it says that nonce is a number that represents the number of transactions which is sent from an account. So before exactly seeing what an nonce is, so if you look at the figure here, this externally owned account has a field called nonce. And if you come to this contract account here, this contract account also has a field called nonce. So when we are talking about this externally owned account, nonce will mean the number of transactions that have been sent from this account. Okay. For an externally owned account, the nonce value means the number of transactions that have been sent from this externally owned account. Now coming to this contract account here also we have this field called nonce. So here what this nonce means is the number of contracts that have been created by this contract account. Okay, you get the difference. The with respect to an externally owned account, nonce here represents the number of transactions sent from that account's address. But if the account is a contract account, then nonce is the number of contracts created by the account. All right. So in Ethereum, we have two types of nonce. The first that we have been talking about, that is the account nonce. And this account nonce acts as the transaction counter. This nonce here acts as a transaction counter. So this is the first type of nonce that is associated with a account. Another nonce is the same nonce that we have studied in Bitcoin. So Ethereum also has been using the proof of work consensus algorithm. So Ethereum uses the proof of work nonce to try to solve the hash puzzle. And we all know what the hash puzzle is. So there are two types of nonce here with respect to Ethereum, the account nonce and the proof of work nonce. So to make it more clear, let us see this with the help of an example. So here we have an example. So this is an Ethereum address here. All right. So we have an Ethereum address here. So if you click on this address, is the screen visible here? So if you have clicked on this address, I will zoom a bit. So this here is an address that we have been talking about. Now, this address has no balance. So it says 0 ether, and in dollar value is also no value is present. And since we are not logging it, the name information is also not present here. So if you see here, this will give you the transactions, it will give you the analytics regarding the ether values that you send or the ethers that you have received, values regarding that. So here, just to let you know, we have a address here. Okay. Now, if you want to see the list of transactions that are associated with that address, so here we have the list of transactions that are associated with the address that we have just clicked. So you can see here all the transactions that are present here. Okay, these are the transaction numbers. We'll see what these numbers mean. Okay, this is the block number in which the transaction is present. Then it gives the age of the block, that is how long ago was the block mined in which this transaction is present. The gas used, the gas limit, we'll see all of these when we talk about gas and ether gas payments, etc. So here, just to give you a brief overview, so we have an Ethereum account, and with that account we have several you can see transactions associated with that account. You can see all the transaction here, zooming in. So you have transactions present. You have age of the transaction, that is when that transaction was created. So here it says the transaction was created on 19th October, which is today. And how long ago it was created? It was created at 1347. Then again we have, I think this has not been updated. It hasn't been 140, it's just 145 right now. So the point is you get the timestamp of the transaction, or rather the timestamp at which the block has been mined. And it also shows the miner which has mined the block. Then we have gas used. Gas used gives us the, say, like, for example, I want my transaction to be included in a block. All right. So whenever I create a transaction, I will include a gas value. And that gas value will be the incentive to the miner that if you include my transaction, you will get some reward. Okay. So this is what gas used is. We will see that, but the point here is that we have a block, we have an Ethereum address, and with that Ethereum address, we have these many transactions included. It gives all the list of transactions. All right. Now, coming back. So if we take one particular transaction as an example, so we are taking one particular transaction as an example. So we are taking this transaction as an example here. So this here we are talking about one single transaction here. And if you look at this, the nonce value is given as 89. So what this 89 means is that you have sent 90 transactions up to this point. So this value 89 means that you have sent 90 transactions up to this point. Why 90? Because this nonce value starts from 0. So 0 to 89 makes it 90. So this nonce here means that this transaction was the 89th, or rather the 90th transaction that has been sent by the account. Okay, and there are several fields here. It has a transaction hash. We know that we hash every transaction. It shows the status of the block, whether it has succeeded or failed. Then it shows the block in which the transaction has been included. It shows the timestamp, that is when this transaction was confirmed and included in the block, or rather when the transaction was like completed. So it was completed on July 30th. It gives the date along with the time, etc. It gives you the Ethereum address from which the transaction was initiated. In this case, this is our own address. And to which account, Ethereum account or Ethereum address, the transaction was sent. The value that was sent was 0.001 ether, that is the amount of ether to be transferred to the recipient of this transaction. And then we also include a transaction fee. Okay. And we have gas price, which we will see what it means, the gas limit, etc. We will see all these fields when we study transactions. But the point here is to understand nonce. So as you see here, this account, can anybody tell me, is it a externally owned account or a contract account? Anyone? Yes, it is a externally owned account because we have value transfer. We are transferring ether from one account to another. We do not have contracts in this account. And each transaction has certain fields in it. So here, the nonce value that we have been talking about, we are talking about with respect to an externally owned account. Externally owned account, as in this nonce value will give us the number of transactions that have been sent from this Ethereum address. Now, the point to remember here is that each Ethereum address will be sending out multiple transactions, receiving multiple transactions. Okay. So that information, the balance information, everything is present inside the Ethereum account. Okay. So this is the nonce that we have been talking about. So the nonce was 89, which means you have sent up to 90 transaction as it starts from 0. Now, if you look at this example here, again we have the same address, our address, which ends with C3E9. Now, the nonce is 119. Okay, the nonce is 119. So if you look at if you just look at this transaction here, the transaction nonce is 119. Now, does this mean your address has sent 120 transactions up to this point? Okay, so to make it easier, this is your account address. All right, CA26. So this is our account address, your and mine. This is our account address. Okay. Now, if you look at this example, your account address ends from CA26. Now, can you tell me this nonce value 119? This nonce value is present as 119. Does this mean your address has sent 120 transactions up to this point? Anyone? So the thing to see here is that when we are saying we have a nonce and with respect to an externally owned account, it gives you the number of transactions that you have sent. But here you can see you are the recipient. You are the recipient here. From address is somebody else's address, to address is your address. So this is incoming ether value. You are receiving ether. You are not transferring ether. You are not sending ether. So when you're not sending ether, your transaction value, your nonce value will not increment. Your nonce value will not increment. So this nonce is the counter for this address. So this nonce is the counter for this address here now. It is not the counter for your address because you are the recipient, you are not the sender. Is it clear? Any doubts, anyone, regarding the nonce value? Anybody, any doubts? You can please ask. I'll be happy to explain once again what we mean by this nonce value with respect to these accounts. Okay. So the reason why this 119 is not our nonce value because we are the recipient and not the sender. All right. So now there is one other important aspect that we need to know with respect to a nonce. Okay. So there are some reasons why this nonce value is helpful. So there are certain reasons why we include a nonce value in a transaction. So we'll see why we need a nonce value in a transaction. So there are certain reasons. So let us look at the reasons one by one. The first reason is that it allows us to send transactions in order. That is, it allows us to send transactions in order. So let us see what we mean when we say it nonce allows us to send transactions in order. Without the nonce, the order in which you send transactions might be ignored. Okay. So let us say you send two transactions within 10 seconds. Okay. So you are, say, user A and you send two transactions. You send this first transaction at the third second and you send another transaction at 7th second. Okay. You send two transactions. And which account you are using? You are using an externally owned account because we are talking about Ethereum transfer. Sorry, Ether transfer. So within 10 seconds, you send two transactions. This is a transaction, this is a transaction. Okay. Now, you might think that the miners might process them in order. That is, if you send the, let us call it transaction 1 and let us call this transaction 2. All right. So the scenario is that we're talking about why nonce is helpful. So the first instance or the first use is that it allows us to send transactions in order. So you have a user A which has an externally owned account, and using this account he sends two transactions, transaction 1 and transaction 2, within 10 seconds. Though two transactions within 10 seconds. Now once these transactions have been broadcasted or once these transactions have been sent, you might think that the miners that will pick up these transactions to be included in a block, they will do in the same order. That is, you may think that the miners will process them in order. Since you send this transaction at third second, you may think that transaction 1 will be processed first, verified first. And since you send this at 7th second, transaction 2 may be verified later. Okay. But remember that we are in a distributed system. There is no guarantee that miners will collect your first transaction first and the second transaction second. Okay. But here is what nonce does. The magic of Ethereum is that you have a nonce associated with the transaction, this account nonce. So what account nonce will do here is that miners will need to process the transactions in the order. Okay, so what I mean is this is a transaction. Suppose this transaction has a nonce value of, say, 30. Okay, we have this transaction 2. This has a nonce value of 31. All right. So since nonce is the counter, that is the transaction counter, if this was sent first, it was 30, next transaction makes it 31. So what nonce exactly does is that nonce will force the miners to process them in order. So this transaction 2 cannot be processed until transaction 1 has been processed because it has a lower nonce value. All right. So transaction 2 has a nonce value of 31. Transaction 1 has a nonce value of 30. So transaction 2 will only be processed only when transaction 1 has been processed. Second advantage is it protects us from replay attacks. All right. It protects us from replay attacks. So without a nonce, a sender could double spend by sending the same transaction twice. So let us again come back to Alice and Bob. So say we have two users or two nodes in our system, Alice and Bob. All right. So let us say Alice signs a transactions and sends some amount of ether to Bob. So Alice, what she does is she will create a transaction, and this transaction says that you are transferring some amount of ether. Say you are transferring uh, 3 ether. So what Alice will do is, we know the drill. She will sign the transaction with her private key because she has to spend the funds. So she signs the transaction with her private key and she sends it to Bob. Okay. So the scenario is Alice signs a transaction and sends some ether to Bob. Now, without the nonce, Bob could copy this signed transaction and keep propagating it until Alice loses all her money. That is, Bob may keep on using this. Alice is only trying to send 0.003 ether. But if there is no nonce number present here, what may happen is he can keep on using the same transaction saying that I am to receive this amount of ether from Alice. But since nonce value is unique, you cannot duplicate the transaction. Okay, so these are the two advantages of using the nonce in a account. Any doubts, anyone? Any questions up till now? Okay, so we'll come back here, and next is balance. So balance means the number of ether that are present, or that is the total amount of ether that you have available with you. Okay, so balance gives you the number of ether that have been owned by you. But if you look here, it says the number V or Y, whatever you want to call it, the number of Y owned by this address. So what exactly is this Y? Y is the smallest denomination of ether. So we have ether, which is the cryptocurrency associated with Ethereum. But we also have, like, if you have, let us take an example here. We're talking about Y. Okay. So if you're talking about rupee, so you have 2000 notes, you have, say, 500 rupee notes also, you have 100 rupee notes, you have 50, you have 20. So there are several denominations in which you have your money. Same is with ether. Y is the smallest denomination of ether. All right. Y is the smallest denomination of ether, and one ether one ether is equal to 1 into 10 to the power 18 Y. So you can see how small a Y is. That is, you put 18 zeros after a decimal point, and that is the value of Y. So Y is the smallest denomination of ether. So similarly, where there are several subunits of ether. There is, say, there is Y, then there is KY, there is MY. So these are the sub-denominations of ether. So you know Y is 1 into 10 to the power 18 Y make 1 ether. So we have KY. KY mean 10 to the power 3 Y. And we have My, which is 10 to the power 6 Y. So Ethereum also has many type of denominations, just as we have with rupee. One Ethereum is 1 into 10 to the power 18Y. Then we have KYs, we have MYs. So there are several denominations in which you can express your ether. Okay. Now, there are GY also, there is micro ether, milli ether. So there are many types of units available with a ether. All right. So this is what we mean by balance associated with a account. That is, you have an Ethereum address, you will have some cryptocurrency ether associated with that Ethereum address, and that information is also present in your account. That information is also present in your account, and these are the denominations in which ether can be expressed. It could be Y, it could be KY, MY, GY, many types of denominations. Okay, and Y is the smallest denomination. So sharing this slide here again. So first was nonce, second was balance. So balance is the number of Y owned by this address. Next we talk about the storage root. So if you're talking about the storage root, we this is a very huge topic. Uh, Let us start this by understanding what a Merkle tree is. All right. So when you say that you have a storage root, so Ethereum also uses a Merkle tree. All right. So Ethereum Merkle tree is known as the Merkle Patricia tree. All right. So if you look here, the Ethereum owned account has a storage root. The contract account also has a storage root present with it. All right. So if you're talking about the, say, the Merkle tree, we already know how a Merkle tree works. So what the tree will do is this tree encodes the hash of the storage contents of this account. Okay. This Merkle tree will perform the hashing of whatever data is put into the account. So if you remember with Bitcoin, what we were doing was we had several transactions inside a block, and we were hashing the transactions again and again and again until we were getting the Merkle root hash. So here also we have a term which is known as the storage root. So storage root, what it does is the storage root will store the hash of the contents of this account, and it is empty by default. Like whenever there is no data or no like content, this storage root will be empty. All right. Then we have a code hash. So we are using this term as like Ethereum virtual machine. We will see this later what Ethereum virtual machine is. But for now, code hash is the hash of the Ethereum virtual machine. Okay. So these are the four fields that are associated with an account. We'll see both this storage root and this code hash in detail when we study about the Merkle Patricia tree. But for now, all we need to know is that every account will have some fields associated with it. First is nonce, we have balance, we have code hash, and we have storage root hash. So these are the four fields, and both the externally owned account and the contract account will have this field. So this is all about the accounts and the fields of the account. So the two accounts, the externally owned account, the contract account, the information that is present inside the account. So these are the things associated with accounts. Next, we will come to the world state, the things that we have been talking about, the storage root, the code hash. We will see all of these, that exactly what do we mean by the storage root, or what do we mean by code hash. So when we talk about, say, your Ethereum, now Ethereum, what it does is it does a mapping between the Ethereum addresses and the account where all the information regarding the Ethereum address is present. So address gives you like, address is like, you can say, your inbox. All right, address is your inbox. But how do you reach that address? You need an email address to reach the inbox. So that is the association between the Ethereum account and the Ethereum public address. Now we need to talk about the world state. So we all know what a Merkle tree is. Now here in Ethereum, we use another type of tree which is known as the Merkle Patricia tree. Okay. The difference in name comes because of the difference in the hashing algorithm that is used. Okay. Here, the hashing algorithm used is not the SHA-256 hashing algorithm. We have another type of algorithm which we'll see shortly. So now exactly what we are talking about is that, like every blockchain, we will have to store the transactions inside a block. And when we are storing transactions inside a block, what we are doing is we are hashing and hashing until we get the root hash, the Merkle root hash. Similar thing we will be doing here in Ethereum. So in Ethereum also, we will be doing the same thing. So let us see what exactly are the things that we hash to get the Merkle Patricia tree. So previously we were talking about the storage root. All right. So there are three types of roots, or three types of, like you can say, Patricia trees or the Merkle trees that we have with Ethereum. All right. So we have, you can see a tree structure over here. This tree structure is the state root. We'll see this one by one. What exactly do we mean by it? So we have a state root. All right. Next, if you come here, you have a storage root. All right. So if you look at this diagram here, this diagram is giving you the, you can say, the fields of a block. All right. We're talking about fields of a block, that what exactly are the fields that will be present inside a block. So as usual, we will have a previous hash, we will have the timestamp, we will have that nonce value, we will have balance. But other than that also, we will have certain other fields that were not present with Bitcoin. And those fields are the state root and the storage root. Just give me a second. Okay. So we were talking about the different Merkle trees that are present in Ethereum. All right. So when we were talking about Bitcoin, we knew that we had just one Merkle tree and that we were using to hash the transactions in order to get the Merkle root. But here in Ethereum, we just don't have one Merkle tree. What exactly do we have is we have three Merkle trees here. One is used for the state, which you can see here. One is used to get the Ethereum state, and hashing and hashing and hashing gives you a state root. Second Merkle tree that you can see here is the storage root. And the third that is used is the transaction root. Okay. So there are three. I don't think the diagram here represents the transaction root, but another field here, we know that we will have transactions inside a block. So apart from all these fields, we will also have a field which is known as the transaction root. So you can see here, there are three roots present: the state root, the storage root, and one another root, which is known as the transaction root. Okay. So we will see this one by one. So the first thing to know here is the tree which we are using here is not just the Merkle tree, you call it a Merkle Patricia tree. It is also called the radix tree or Patricia tree, and it is a data structure, and we know how this data structure works. So the algorithm or the hashing algorithm, the hashing algorithm used by Merkle is called KECCAK. So this is the name of the hash algorithm that is used in Ethereum. We don't use SHA-256. We use algorithm which is known as KECCAK 256 algorithm. Okay. So the Merkle Patricia tree uses this algorithm. When we were using the Merkle tree in Bitcoin, we were using the SHA 256 algorithm. We were using the SHA 256 algorithm. So now we'll not get into detail because this will be a very big topic on its own. The point the point that we need to understand here is that why are we having three different trees? What is the reason for having three different trees? Here we were using Merkle trees for just transactions so that we could get to the to the Merkle root. Here we are using the Patricia tree for three purposes. First is storage root. Second is state root, and the third is the transaction root. This and this will be the same. This will be the root hash, transaction root hash. So this is same. Additionally, we have two other roots, which is known as the state root and the storage root. So what exactly do we mean by the state root, the storage root, and the transaction root? So for each of these we have trees. For getting state root, we have a tree here, Patricia tree here. For getting the storage root, you have a Patricia tree here. For getting the transaction root hash or the transaction root, you will have another Patricia tree. So my point here is that you have three different trees in Ethereum block. All right. So we need to see each of these one by one. So the first that we will be talking about is the state root. So what exactly do we mean by state root? So this is a very difficult concept, but we'll try to summarize it. I'll try to summarize as like easily as possible. But before we start with the state tree or the state root, the Ethereum has a like four type of, you can say, fields that we have been talking about that are present inside a block, sorry, present inside a account. So these are the fields, the nonce, the balance, the code hash, and the storage root. So this value is present inside the account. But when we are talking about a block, the amount of information that will go inside a block, that will vary. Then what you're doing is you have transactions that are having certain parameters. And apart from that transaction, you are storing the balance, you're storing several other information, and that information is stored in this world state. And the world state means the global state of the Ethereum blockchain. All right. So the world state is the global state, that is the mapping between the addresses and the Ethereum account. That is, every time a transaction occurs on the Ethereum blockchain, the state of the Ethereum blockchain is updated. Why it is updated? Because we create a new block and we add a new block to the blockchain. So this is what a world state means. That is, whenever the transaction occurs, the global state of Ethereum is constantly updated because of transaction executions. Okay, so this is the world state. We'll talk about where are we? Yes. So this is the state root here. State root means that whenever an update to the Ethereum blockchain is made, that is added to the state of the Ethereum. Okay. So next we have is storage root. So an account in Ethereum has nonce, balance, storage root, and code hash. So what exactly do we mean by the storage root? Now the storage is where the data associated with the account is stored. Okay. All the data that is present within account, that is stored in the storage root. That is all the information about me, my Ethereum address, how much my account has, how many transactions have been sent, how many transactions have been received, what kind of codes I have executed. All of those information is present in the storage tree here. So we have already seen the storage root. By storage root, we mean all the information that has been associated with a Ethereum account. All that information is hashed and hashed and hashed until we get a root hash. Next, the third type of, you can say, the root hash that we need to get is the transaction root hash. So the state of Ethereum is changing because the transactions are getting executed. So transaction plays a very crucial role to the change of Ethereum blockchain. And once a transaction is recorded in a block, it cannot be changed. It permanently becomes part of the Ethereum world state. And transaction tree or these transaction root is constructed with the help of the Merkle Patricia tree. And only the root node or the root hash is stored in the block. So I think we'll stop here and we'll continue, or rather, we'll discuss this again, the three roots, the state, the storage, and the transaction root to make it more clear. And then we'll move on to the transactions. So I'll stop here. If you have any questions, please do ask. Otherwise, we'll take this up again in the next class because it needs a lot of explaining.